Um, Question D is very similar to the previous question. We have some trig function with weirdities going on there, and we're multiplying by something. First thought should be let's just throw in 0 and hope for the best. But alas, when we do that, we get 0 to the 2/3, which is 0, times the sine of 1 over e to the 0 minus 1. E to the 0 is 1, so we get 1 minus 1, which is just 0. So again, we're dividing by 0, which is infinite. This thing blasts off to infinity. In this case, it blasts off to a positive and a negative infinity. I know you care about that. So then let's do the same thing we did in the previous question. We know that the sine of anything is going to be bound between positive and negative 1. That's the range of sine. So 1 over e to the x minus 1 counts as an anything. So we'd say that the sine of 1 over e to the x minus 1 is going to be bound between positive and negative 1. So then we have, again, this part already. The only thing we're missing is x to the 2/3 times it. So in order to get x to the 2/3 times, we've got to multiply everything by x to the 2/3. So everything here is going to get hit with an x to the 2/3. Right, distribute, distribute, distribute. And we're going to be left with negative x to the 2/3, right? Because negative 1 times x less than or equal to x to the 2/3 sine 1 over e to the x minus 1 less than or equal to x to the 2/3. Right, so we've now built our function in the middle, the thing we want to take the limit of, right? We're not taking the limit of anything yet, so we got to apply this limit or take this limit of every term that's in here. Right, so a limit as x approaches 0 of everything. Distribute, distribute, distribute. And that's going to give us the limit as x approaches 0 of x to the negative 2, or negative x to the 2/3. Limit as x approaches 0, the thing we wanted, and the limit as x approaches 0 of x to the 2/3. All right, so then now we're bounded, right? Our limits are bounded, so I can take some limits here. If I plug in a 0 using the substitution rule, 0 to the 2/3 is 0. Negative 0 is still 0. If I plug in a 0 here, I'm going to get 0 to the 2/3, which is also 0. And so then once again, this function in the middle, or this limit in the middle, I should say, must also be 0 because we're squeezing it between two zeros. So this limit equals 0 by the squeeze theorem. And all of this work to kind of build the function shows me that you know what you're doing with the squeeze theorem.